Welcome everyone. My name is Aleander Trost. I'm working for Cloudical, and I'm going to talk to you about Kubernetes security, achieving confidentiality. So let me get started here. To go over the agenda, we're looking into a short recap of the webinar on 2nd June. Then that one will be done by Jurlind. After that, I'm going to dive into shortly a bit of cluster architecture for Kubernetes, on then the part of encryption, persistent volumes there, secrets in etcd, and then finally to the last point, access control, RBAC, and your workload. And with that said, Jurlind, would you take over?
Sure. Yeah, so last time we had the chance to look at the Aqua Security native platform for Kubernetes that was building on the seminars that we had the weeks before. While there we were introducing you to some open source tools. In this case, we had the possibility to see the commercialized version where you have all the opportunities and the features with respect to visibility onto your cluster or visibility of your policies and visibility on your security posture, be this within a cluster or across clusters. You can see on the below when it starts with the CI/CD while scanning your images and looking with respect to vulnerabilities that these images might have, and not only but also dependencies of these images on their libraries or applications that they provide. And also to the end, going to runtime, looking at the policies that you are enforcing, to the firewall workloads, looking at what workloads are talking to which workloads, and finally compliance, making sure that the policies of your company have been enforced, and so you have the possibility to check or even to report them into a centralized ZM or analytics tool. Yeah, with that said, that was actually what we saw last time, and I will hand over to Alex, and I'm excited to hear what he's gonna tell us today.
Yeah, so as I already said, for the first part of the topic Kubernetes security, we should get an insight into the cluster architecture of Kubernetes. For that, just very much broken down to like the most basic components, even having left out some. For the master parts, you normally have an etcd. The etcd is basically the brain of the Kubernetes cluster. It contains all the data, all the objects that are created of the Kubernetes cluster. And in front of the etcd, you have the API server. It's basically kind of, as you can think, the etcd is like the API server is basically kind of like a gateway in front of the etcd. This is the only component in a normal Kubernetes environment which has access to the etcd. In front of the API server, you normally have API load balancers and such. That's, well, oh, I just found a typo in my graph. And the other components, like on the master thing there, kube scheduler, kube controller manager, might use the load balancer. They, depending on the setup, they might also directly locally connect to the API server. Well, the components on like the worker, for example, the kubelet and the kube proxy, and to even extend on that, if you've heard about operators in Kubernetes, they also normally use, well, like some kind of load balanced address to reach the Kubernetes API to be able to do their to do their things. So this is it, like a rough structure, a very rough structure of Kubernetes cluster, and we need that for our for the further coming parts. Okay. So we have, for the first part, the part of encryption and persistent volumes. The point of encryption and persistent volumes there is that you have a storage backend, a storage provider. For example, if you're in a cloud, you have a provider which supports that to either have, depending on what your security requirements are there, or more or less the risk you're willing to take, is depending on where the data is encrypted. There are certain providers and storage backends which allow you to have, well, for example, the data where it's stored. So for example, in a cloud provider, where the cloud provider stores its data, that they have encryption on the disks there, but also that you, for example, mentioning Ceph CSI here and Ceph in itself on the slide multiple times, because they, for example, support the persistent volumes themselves when they are mounted on a host to be encrypted already. And Ceph itself can also, especially they're mentioning Rook, as I'm one of the Rook maintainers, so I had to mention it. The Ceph itself will also, the Rook Ceph will also look into improving the support there, that you can run it basically on the encrypted disk itself. So the data you store that is encrypted, and then the data itself that is already encrypted will be saved on disks which are encrypted again, plus other potential metadata, to put it like that, as it might seem redundant there to have 2 layers of encryption. But still, in certain scenarios, in certain security scenarios, it simply can make sense to have encryption in regards to that is where the actual data is stored, and encryption where the volume is mounted. So double doesn't make it better necessarily, but it can have certain advantages depending on the scenario set. So that's basically the point there with encryption for persistent volumes. You can either have it at the back end, so to say, or, well, it's not the front end, but for a storage side, it's technically the front end. So think about it, where you would need it and where it would make sense, like as we have it, I think, with most parts of security there, and there's also confidentiality. It has to make sense where you apply it. Otherwise, it's just making things problematic or, well, broken, to put it really like that, for certain scenarios. So, yeah.
Yeah, would you say, Alex, that it makes sense to have encryption while you have this, the possibility, as you already explained, to have this in 2 different places? I know for sure that there are, for example, cloud providers that they don't necessarily support this encryption by default. So is this, would you think, a use case where you would really look into those solutions that you already said, where you would have this encryption provided by the storage solutions instead of the disk encryption not supported by the cloud provider? So this is maybe a use case where it makes sense, right?
Yeah, it can make sense, but as said, it depends on what storage you're using. In this case, especially it's Ceph CSI supporting that, and at least I think I haven't really heard of any other storages implementing this. Maybe some other CSI drivers for storages, but at least from my knowledge right now, Ceph CSI is one of them, simply that supports it on a persistent volume level and on the level of on disk, simply because Ceph technically uses whatever is a disk. As long as, well, yeah, it's a disk, you should be able to use it for that. So, oh well, yeah.
Yes, sounds great, because I'm for sure, as I know, there are cloud providers that don't use encryption on disk, and this is very, let's say, a struggle, or it's very challenging then to encrypt the data if the cloud provider is not supporting that. So maybe this is a point where people should think about it, what kind of storage solution, software-defined storage solution they need to look at in order to maybe fulfill a requirement of confidentiality and encrypting those data.
But there again, it's more or less a waging of, are you okay with the risk that if your cloud provider is compromised to a certain level, like someone would really need to get pretty deep into this infrastructure of the cloud provider already, if you're fine with that. And at least from my perspective, unless you're like a bank or something, or like having a like really 100% well 100% in quotes, you know, security / encryption or something, you know, concept going on, there's not necessarily too much point in every cloud provider implementing this. I said, because in the end, even if you have bare metal, someone, like, you can still argue that, well, if you don't encrypt, someone needs to go through the whole data center entrance and such first, which should normally be secured, well, good enough, and or your employees or the people at the data center, to keep it more generic, should be, well, to put it like that, scanned enough, secured enough for the job. So there's no like, yeah, let me just take this disk from the server or something. So it's, as in the end, simply a big, especially for management side, a big, well, comparing the risks, and in the end, simply differently put, it's not really comparing the risks. It's more, are we thinking we can take this risk in the end as well? Because you always take a certain risk, even if it's a very, very small one. So yeah.
Yes, that is very true. So depending on the context you are actually using in your environment, depending on the model you are using in your environment, I completely agree with you. When it comes, if you are not, let's say, or if you are only co-located in a data center and nobody else is running on your physical machines, or in the machines, be those also virtual machines, and nobody else is using them except of your company, and you are making assumptions that your employees are behaving securely or they are trustworthy, and they would not access or dispose these data to external parties, then I guess this is not even necessary. So I agree with you that access control at this point is the other measure that you are going anyway to talk about. Nevertheless, if we talk about multi-tenancy approaches, where you have a machine that is shared maybe to different customers, where they have different conflicts of interest, there are the cases I suppose you are addressing to when you say that encryption is something that you need to think about it to achieve confidentiality.
Yeah, as we had it, it's simply depending more or less on the well, on what the needs are from yourself, yeah, exactly. And well, from the security side. So let me go ahead and continue with the next part of the whole presentation. One thing with the ADSD, if you remember back with the diagram here, let me just go a bit forward there. We have the ADSD being the, let me, well, I have it. We have the API server accessing the ADSD. And the API server, well, the ADSD is holding every object in the cluster. So it's basically kind of like a library, if you will say. It's kind of like a library of all the objects in your Kubernetes cluster. And those Kubernetes clusters, those Kubernetes objects also include secrets. And those secrets, normal Kubernetes objects, they're as well saved, well, in the API server, and the API server is saving them in the ADSD. So one thing that the Kubernetes people have come up with there is the so-called encryption at rest. Here we go. That's where something like, especially in a cloud environment, something like KMS, Key Management Service, comes into play, where, well, it's normally, as it kind of already implies, it's a service that you can get from your cloud, or there's also services in some way for bare metal and, you know, like those metal-y environments, which basically allow you to have a dynamic key going on, which is used by the Kubernetes API server to encrypt the secrets. So we have normally a Kubernetes secret is nothing else than a value base 64, and that is a secret. And base 64 is basically nothing. So that is one way to at least where the data is stored, to have more security there. Because if someone would be able to go onto a master server, well, they might be able to access also other credentials. There are, well, certificates and such to be able to directly talk with the API server. But if, let's say, they would only have access to the SD server, for example, and would be able to copy the SD data, at the moment, it would be a secret of base64. The data is, well, basically in plain text available of those secrets. So the idea with SL with the encrypted rest is that you have some servers, for example, K8s, or you even have static keys, which are used to encrypt secrets with. And if you think about it, like, it might not make too much sense from if you think about it as of right now, but if you encrypt those secrets and save them as encrypted on the SD, you have one less risk there that someone might be able to access the SD if you don't want them to access, and you, well, you know, unauthorized access, they're able to enter it without you knowing it or something, able to take the SD data there or something, for example. And then you would not have to fear too much of this problem. You should, well, you should still rotate all your secrets if you have the possibility, if you know that it happened. But in the end, you at least have had more going on there, that the data that is stored in the SD is secure. And to even go a bit further here, it might in the future, who knows, maybe it's at one point not even SD anymore. Maybe it's just, maybe it's just some other database, kind of key value database or something that might be implemented there, or that is really going to be more pluggable than as right now. As at least with the, from Ranger, the K8s project, I think. Oh no, it was the, I think it was the K8s project. I'm probably wrong with that name, but at least from the Ranger guys, they have implemented, for example, MySQL, or I think it's even a pretty more or less like a just plain SQL interface. So you can use something like a MySQL database instead of an SD there, for example. And also in those cases, basically, why not? Why not have additional security for your secrets there? If you're using plain Kubernetes secrets, that's your only way to go, basically. If you, especially if you use applications from other people, which, for example, don't have integration for, well, other security management, not security, secret management, software, or products, well, for those, you still would need to use secrets in some way. So that would still be one of the ways to go there, kind of. Now, let me check here. As to kind of put it into perspective to, well, to how simple it can be to at least have a static key for encrypting the secrets that are written to the SD and then, well, again, read from the SD. It's just a bit of YAML you need to give the API server. Any API server based on that will, for example, this would use, well, I think it should have been 16-bit, 32-bit or something, long string here. They have a pretty good documentation about that. On how you would need to set it up. It's pretty simple to set up, though at least if you use static keys, you should also think about like rotating the static keys from time to time. But just as a, well, for your information already, don't just change the key, and you're not good if you just change the key. Because if you change the key, all existing secrets would be lost, because the API server doesn't have any way of decrypting them because you just remove the key. You can simply go ahead and plug in a second key, and that's basically the good. The documentation from Kubernetes side has everything noted down there and what points you should look out for. And so, well, yeah, there's not too much to say there besides that.
Yeah, so maybe before we go to the next topics, I'd like to mention, Alex, that what you already were emphasizing, that, of course, when we talk about base64, as you can see there, it's written encoding. So it's actually no encryption at all, but it's just encoding of binary data that is let's say, representing in ASCII format. And the reason we decide that is due to networking, to be able to transmit the data from one side of the network to the other side without being corrupted, because you cannot like simply transmit binary data as they might be interpreted in between. So this is where base encoding it's coming into play. So there is no encryption in there at all. So this is the reason. So don't think just because it looks cryptic that there is encryption on that. And it's exactly what Alex said in the last point. It's very important when you think about a key management service or system or whatever you want to name it. You have always to think about it of a key life cycle. Because the moment you lose the key, as already mentioned, you are going to lose your data that has been encrypted by that key. So this is very dangerous. So think about it, maybe also having a backups of your key, or think about it when you use your key management services of having a full key life cycle support, where you are able maybe not only to back up the keys, but to retire them, or to use, let's say, features like perfect forward secrecy, when you can rotate the keys, or you can use session keys. So these are things you have to think about it in order to implement this, or to implement encryption at this point correctly. And exactly, if you don't encrypt your secrets, then everyone that has access, let's say, to the it's going to be able to access those secrets and maybe look into the data that they shouldn't look into. So they would violate kind of the requirement of confidentiality at this place. So exactly, look after these ideas. And as Alex has put it here, it seems very straightforward. Nevertheless, keep in mind, you have to think about the big picture in here, and not just using the key and maybe deleting, but yeah, as you might tend into do with this YAML configuration files, and you might lose the key. So bear that in mind. Yeah, so thank you, Alex. That's all I just wanted to add in here. You can continue with the access control.
I'll go ahead. Yeah, so for the last point there, access control, RBAC, and your workload. For the people that don't know what RBAC is, well, basically the way in Kubernetes, it's a role-based access control. So it's basically the way to say, give users, or in Kubernetes terms, users, groups, or service accounts access to a certain role. And that role, depending on the scope, if either cluster-wide, so cluster role binding, or in a namespace, localized namespace, would be role and role binding. There's also a bit of cluster rolling, but and that's the point there of RBAC. And RBAC is cool and all, but you need to keep it tight in regards to the access that applications can have, and especially service accounts which applications are using, which might not even be in need of having access to the Kubernetes API. So the point more or less about this topic is that you should keep your permissions of your applications tight, always as tight as possible, so that you're not coming across a crime scene if I know I'm talking a bit bad here with that about developers, but it's not a developer accidentally had more permissions on the application, which then did something against the Kubernetes API or something, which, well, broke something or even just deleted something. So it's important to keep of your own workload tight as possible, but also on things you install from the internet to collect it. And if you're using Prometheus operator, they have pretty tight RBAC permissions, even for the point of you have it cluster-wide, but also namespace to a certain namespace there. They have, well, everything documented pretty good in that regard. And as I just by keeping it as tight as possible, an application won't have unnecessary permissions. You might say, oh, well, they're not necessary for the application, or, well, for the workload. But what if someone bad sees that, oh, there's more permissions on the, for example, service account token of an application and does something bad with those permissions. So as I said, keep the permissions as tight as possible for your workload and applications, and more or less as a, hey, best practice, it is recommended that you don't, unless really, really necessary, modify the default cluster roles. Instead of modifying the default existing cluster roles, you should use the so-called aggregated cluster roles. That is a feature with which you can have the normal existing cluster roles. And if you create your additional, well, your changes to cluster roles, or more or less, it's more an addition to cluster roles, and label it in a certain way. There's a whole documentation about it. Then the permissions that you have in the other cluster role will be aggregated with the default cluster role, allowing you to, for example, if you have, if you're utilizing like the default cluster roles, cluster admin and view and such, you would be able to, for example, if you use custom objects, to with ease add those permissions for those custom objects to those default existing roles without having to modify them. And yeah. As a last point, more or less just as a good to mention here, are third-party service account tokens. Not to get into too much detail there, they're basically a way of using an external, well, token mechanism. As it like, I'm trying to keep it a bit simple here, very simple and rough here. Because normally the first party, so the original Kubernetes service account tokens, they are never running out. Well, there are a few scenarios where they're running out, but from a normal Kubernetes cluster standpoint, a service account token will never be invalid unless the secret in which this token is contained in is deleted. And I'm thinking about the feature, the third-party service account token is basically that you have an external point, or well, a central point where applications go, or well, Kubernetes in this case, more or less, will go to, retrieve a token, and that the application, well, or Kubernetes is normal with tokens like that, need to go to every now and then to retrieve an updated account, an updated token for their cluster. So yeah, but there again, it plays into keeping your permissions tight, because if you keep your permissions tight, you don't have too much to worry about, even if you use third-party tokens already, about abuse there too much, or at least only abuse of the permissions you have given any token in your cluster. So yeah, that's that basically.
Yeah, so maybe to add on that, or to specify that, when we talk about give your permission or keep your permission tight, you always need to keep in mind the two principles that are mostly implemented in here. One is the last privilege, and the other one is need to know. So please think about it, about your own developers or testers, or whoever the users of your cluster are, think about them in this role-based access control. It gives you a lot of flexibility in order to use groups and to group people within that roles and to give them permission. So you have a good overview how permissions, or what each person or each user or each service account can do within a cluster or within a namespace. As we understood from Alex, we have the possibility either to have a cluster role, meaning that you have permissions within the whole cluster, or you have the so-called role where you have permissions which are namespace scoped, so that you will have permission only within the namespace, or where you define this role, you need to specify the namespace where you define the role, and then you have these permissions only in that. So keep that in mind, that with that big flexibility or the ability to use that, it also comes the responsibility of making sure and understanding your environment, who is going to be your users or your service tokens, and what kind of access do they need to perform their tasks, and just give them these roles, so at least you do your the homework from your own part and keeping your system tight and adding to the security levels on the different layers. So we are touching here.
No, exactly. That's no. Okay, so to round it up with the ABRAC here again, as I said, you wouldn't just keep your keys sticking on the door. You would, well, remove them, or at least only give the key to people that should really have access. So to round up the 3 points mentioned, let me quickly just summarize it. We have the Kubernetes, well, 4 points with the Kubernetes architecture there. As a rough Kubernetes architecture, you have etcd, you have kube API server, you have kube scheduler, you have kube controller manager, kubelet, and kube proxy. There's a kind of like a normal components. There's also like a software-defined networking, CNI and such as well included, but I left it out just from Kubernetes perspective. That's the normal components of a bare-bone Kubernetes cluster, basically. So we have it about encrypting the storage. You basically, it's more or less a thinking of if you trust your cloud provider as well, like if you're in a cloud, do you trust them to handle your data secure enough, or do you want to add another layer of encryption, or even the first layer of encryption, depending on if the cloud provider is encrypting the data on top of that? Or do you, for example, if you run your own storage, are there possibilities to encrypt the disks on which the data of the storage backend is written to or something? For example, for what I didn't mention, for object storage, for example, that's more or less also a trust thing. If you trust your cloud provider, which offers you object storage, if they encrypt it. But yeah, so that's basically more or less the idea there, that you think about, is it a good idea to do that? It might have performance impacts on your applications and such. Yeah, well. With the next part is with the etcd. As if you're in a cloud or in general have like a key management system available, make use of it. It's not like they're more or less, it's pretty easy to use. It might be a bit, well, it might be a bit complicated if like it's a weird K management system or something. But as I said, like Kubernetes documentation at least should help you at least for most common scenarios. And yeah. And for the last point, I said, keep your RBAC roles as tight as possible, and if possible, don't modify the default cluster roles. And yeah. And well, that's it from the summary. Thanks for listening, and thanks for watching. Jan, do you have any points to bring up from your side?
No, I just wanted maybe to ask if there are any questions from the attendees, so they have the possibility to post any question in the Q&A, and we would be glad to answer them. Otherwise, yeah, other than that, I don't have anything to add. So thank you, Alex, for this nice overview and for having prepared the webinar for today. So with that, I think we can then close it for the day, right?
Yes, I think so. Yep.
Okay. Yeah. Thank you for listening. See you next time.
See you next time. Bye.